Hello friends, welcome to chapter 3, section 3.1, working with Keil MicroVision 5 integrated development environment. The outcomes of section 3.1 are learners will be able to create project in Keil MicroVision 5 integrated development environment, write assembly language program in editor, understand the process to create hex file, simulate and debug the program. About ARM. ARM is an organization which develops microcontroller hardware and software tools. The Keil MicroVision 5 IDE demo or evaluation software can be downloaded from the link given here. This is the link to download the Keil MicroVision 5 IDE demo or evaluation software. Now let us see the process to create project and hex file in Keil MicroVision 5 software. This is the icon of Keil MicroVision 5 software. Double click on it. This window appears. Click on project, new MicroVision project. Now select the location. On desktop, we have created one folder, My Programs, and here we will do all our work. Write the name of the project here, My First Project. Save it. Select the microcontroller to be used. We will select microchips. We will select AT89651ED2 microcontroller because we shall use the hardware of this microcontroller. The description of microcontroller appears here. Number of I/O ports, timer counters, on-chip memory capacity. Entire description is given here. Click on OK. Say yes. Click on File. Click on New File. And editor appears. This window, it is known as editor, where user has to write the program. This is the project workspace. All files will appear here. And this is the output window. So errors will appear here in the output window. Programmers are supposed to write a program into the editor. So start with org, means origin 0000H. The first instruction of the program will be loaded at address 0000H. So let us write one label start. Now for example, we will write one program to toggle the bit P1.0. Set B P1.0, call a delay, clear pin 1.0. A call my delay and jump to the beginning of this program. F jump start. Now let us write a delay program. My delay. Now let us use 3 registers R5, R6 and R7 to create a delay. So delay program will be like this. Move R5, comma hash 0FFH. In my delay program, R5, R6 and R7 registers are used. In R5, R6 and R7, hex number 0FFH is loaded. So first R5 is decremented to 0, then R6 is decremented to 0, then R7 is decremented to 0 and delay is created. Subroutines terminated with return, and every assembly language program should be terminated with directive end. Save this program, name this file let it be toggle pin dot asm. We have written the program in assembly language, therefore its extension must be .asm. Save it. Click on source group. Click on add existing files to group, source group. Right click on source group. Click on add existing files to group, source group 1. Now already we have saved the togglepin.asm file. Click on that file. Click on add. Automatically it will get added. Here you can see that file is added to the source group. Click on close. Now 3 build options will be enabled here, 1, 2 and 3. Now click on this build icons. If there is not any error in the program, the output window will display the message like 0 errors, 0 warnings. Click on second build option. Click on third build option. Click on project. Click on options for target 1. This window will appear. Here write down the frequency of the crystal which is used on the hardware board. Suppose crystal frequency is 11.0592 MHz. Click on output. Check create hex file box to create a hex file. Click on OK. Now click on the build options. Minimize this. Click on objects and hex file will appear here. This is the hex file. This hex file we have to load into the microcontroller. So minimize this. Let us see how to do the debugging. Now for debugging, click on debug, start debug session, or directly you can click on this symbol. So this is the evaluation version, therefore its code size limit is 2 kilobytes. Click on OK. Now here we have used port 1. Click on peripherals, select IO ports. So all ports and all on-chip peripherals of selected microcontroller will appear here. Since we have used pin 1.0, we will select port 1. Now click on reset. Now perform single stepping. So you can see here set BP 1.0, a call delay, so it will jump to the delay. Now this my delay program will be executed. So directly I will come out of my delay program by clicking on this step out option. Now this clear P 1.0 instruction will be executed. So I will click on this option and you can see the bit P 1.0 is cleared here. Again I will execute this instruction, a call my delay. So execution is transferred in the my delay subroutine. Here every time registers will be decremented. So I will come out of my delay subroutine by clicking on this step out symbol. So again, yes, jump start. So again, execution will start right from beginning. So this will get repeated, and every time the pin P1.0 will be toggled. So multiple facilities are provided by Keil MicroVision. So users can use the appropriate facilities. Now come out of the debugging mode. So in this way, users can use the Keil MicroVision